We're going to begin the second part of our discussion on interest by talking about compound interest, but I thought it might be helpful to just do a brief summary of what we talked about in the first part of the discussion. And basically that was that there are two types of interest we'll be talking about. That is simple interest, where the interest itself never earns interest. Only the original amount you put in, the principal or present value. And compound interest, where the interest itself goes back into the account and begins to earn interest. And again, simple versus compound. Our last discussion, the first part of this discussion, was about simple interest, and now we'll pick up with compound interest. So here we go. Most interest-bearing accounts actually pay compound interest, and as I said before, that means the interest itself goes back into the account and begins to earn interest. In order to calculate the amount of interest in a compound interest account, one of the things you have to know is how many times during the year the interest is paid and added back to the account. This quantity is called the compounding period. Now, some simple compounding periods are typical compounding periods. Annual compounding means the interest is only paid once a year. Semi-annual compounding means the interest is paid twice a year, every 6 months. It goes back into the account every 6 months. Quarterly interest is paid 4 times a year. Once every 3 months, the account will pay interest back into the account, and that interest at that point will begin earning interest itself. Monthly interest is once a month. Obviously, that's 12 times a year. And daily, sometimes a problem deals with something called a business year, which is not necessarily 365 days. But for purposes of what we're doing, we'll just always say the interest for daily interest is 365 times a year, unless the problem specifically says otherwise. Anyway, you have to know the compounding period or you can't solve the problem with compound interest. The formula for calculating compound interest is capital A is equal to capital P times the quantity 1 plus I raised to the n power. Does not do you any good at all to know the formula if you don't know what the parts mean. So as before, capital A is the accumulated or future value of the account, just like for simple interest. Capital P is the principal or present value of the account, just like for simple interest. Now here's where you get a little bit different. We introduce a little I, and little I is little r over little m. Little r is the same thing that it was before, namely the annual interest rate. And little m is that quantity we talked about earlier, the number of compounding periods per year. So m is how many times per year the interest is paid back into the account. So little m is the number of compounding periods. Little r is the annual interest rate, same thing we're dealing with simple interest. And little I is the quantity by taking little r and divided by little m. And what you get out of that, when you divide the annual interest rate by the number of compounding periods, is you get the interest rate per compounding period. So if you had quarterly interest at 8% quarterly interest, if you take 8% and divide by 4, you get 2%. That means you get 2% of it each quarter. 2% the first quarter, 2% the second quarter, 2% the third quarter, 2% the fourth quarter. That's 8%. So you're actually, to get the little I, you're dividing the annual interest rate into pieces based on the compounding period. And finally, little n is the number of times the interest is paid, and that's easy to see that it's going to be the time in years that you keep the money in the account multiplied by how many times it's compounded per year. So little n is m times t. So if you've got quarterly interest for 5 years, that would be 20 compounding periods through the course of the loan, 4 per year for 5 years. So little I is the interest rate per period, and it's calculated by dividing r by m, and little n is the number of times interest is paid over the entire course of the time the money is left in the account, and that's little m times little t. So with that information, we can solve problems with compound interest. For example, $2,000 is deposited in an account paying 4% annual interest compounded quarterly. How much money will be in the account after 3 years? Well, first of all, you need your formula, and then you have to identify what each quantity is. The principal is the amount you put in the beginning, the principal or present value. That's $2,000, so that goes in. We have to calculate that little I. Notice the formula has a little I in it, and we know that little I is little r over little m. Well, R is the annual interest rate, just like it was for simple interest, so that's going to be 0.04. And little m is the number of compounding periods per year. It says compounded quarterly. Quarterly means 4 times per year, so m is 4. And now we can calculate little I, 0.01. So it's a 4% interest rate paid out quarterly, so that's 1% each year. And we can plug that into the formula now. We also need to know n. Well, we know, of course, that n is m times t, and we know that m is 4, and we know that t is the number of years, which, if you look above here, is 3. For 3 years. 4 times 3 is 12, and we can plug that in. And so now it's just a matter of using a calculator to calculate this quantity. Let's bring it up and do it. I'm not going to show every calculation every time, but I will do this one. First thing I want to do is start inside the parentheses. So I'm going to do this. I'll take 1 plus 0.01 and then hit equal. When I do that, I get 1.01. And then I want to raise it to the power of 12. So again, let's just make sure you saw that. The power button is the one labeled x to the y. So after I get 1.01, I want to do the power button, and then I want to type in 12. So I do 1, 2, and then equal. You need to practice this. When you press equal, you'll get 1.12682503. You don't want to be rounding these things off. Just leave the quantity in the calculator. Now you want to times that by 2,000. So it's times 2,000 and then equal. And that will give you $2,253.65. Do another one. At birth, a deposit is made into an account paying 4.8% annual interest compounded monthly. How much money must be put in now for the account to be worth $60,000 in 18 years? Same formula. It's compound interest. We use the compound interest formula. We identify each piece. This time, we know A, and we're looking for P. Why? Because it says how much should be put in now. So they're asking for P. We don't know that. They want us to tell it. They want us to find P. But they want it to be worth $60,000 in 18 years. That's in the future. So that's the future value. So that's A. So 60,000 is the A. So in this problem, they're asking us to solve for capital P. So we plug 60,000 in for A, and then we got to figure out what little I and little n are. So we start off as before. Little I we know is little r over little m. Little r is the annual interest rate, 4.8%. Write it as a decimal, that's 0.048. M is the number of compounding periods per year. Monthly is 12 times a year, so M is 12. Take your calculator and do the division, and you'll get 0.004. Now we can plug that in. But before we do that, I want to remind you that if you haven't done much with your calculator yet, when you take 0.048 divided by 12 and hit an equal sign on that calculator, you're not going to see 0.004. What you're going to see is this quantity here. That's the calculator's version, its version of scientific notation. Now there's a video that I hope you've already watched that talks about this, what that means, but you have to be able to interpret that. And what that really means is you take the 4, whatever's in the base of the display, and the decimal place is after the 4, and this -3 means you move the decimal place 1, 2, 3 places, which means you have to add 2 zeros. And so what you learn from that is that 4 with the -3 in the display as an exponent is 0.004, which is what we said here. So you need to, if you're having trouble with that part, you probably want to watch the video that I provided on calculator tips, and it tells you more about that. So that's the calculator's version of scientific notation here. But in any case, you end up with 0.004. And that can be plugged in. Now we need to know what little n is. And we know that's little m times little t. We've already decided that m is 12. And we know we're doing this for 18 years. So t is 18. And 12 times 18 is 216. So now we can put that in for n. And now it's a matter of doing the calculation. I'll do this one again. I want to start on the inside of the parentheses here. So I will do 1 plus 0.004 and then equal. And that gives me 1.004. I want to raise that to the power of 216. So I do the X to the Y button, that's the power. And then I type in 216. So 2, 1, 6, and then press equal. And that gives you 2.36854,678. Now we're solving for p, so I need to divide both sides by that 2.36854,678. And if I do that, I end up to the nearest cent. We're working with dollars and cents. Unless you're told otherwise, you'll just round it off to the nearest cent. $25,331.99. So if you want to end up with $60,000 in 18 years and you're able to get 4.8% compounded monthly, you would need to put $25,331.99 into the account in the beginning so that it ends up being $60,000 in 18 years. Again, know the formula, know how to use your calculator, and practice the technique.